All right, stuff in front of me. So in this session, we're going to talk on why and how to upgrade to Java 17. My name is Johan Janssen, and I work for Sanoma Learning. And this is more or less the agenda, but we'll see that in a second as well. If you have any questions, please feel free to add them to the chat. I saw that I have to post the link separately, so I will do that later. If you have any other questions, please just let me know, and I'll try to keep track of the chat and answer them in between. You don't need to wait until the end. If you have any questions later, also feel free to contact me to Twitter, LinkedIn, or whatever means. This session is based on a GitHub repository I created, Java upgrades. I will show it later as well, but it contains a lot of the information you will see here, so it might be helpful as a reference when you start upgrading your application. So a little bit of background. I didn't got all this information from Googling. I actually am doing Java upgrades for many years, from 8 to 11, and even before that, in various companies for not only Hello World applications, but for big applications in general. So it's not like migrating Hello World, it's migrating really big applications, multiple applications for many years. While still, of course, Googling, because, I mean, if you encounter any issues, Google still is your best friend. But first, why should we actually upgrade to a new version of Java? There are various reasons to do that. And not only upgrading like major versions, like from 11 to maybe 17, but also upgrading to the latest minor version already gives you all kinds of improvements, such as for performance, for security, issues that have been fixed. You make sure that you still get new versions released for your major version of Java. And I think for us developers, the most interesting part, of course, is the new features, the language features that we can use, just as records and pattern matching, which was talked about a lot already at this conference. And I think nowadays it's quite hard to keep and attract employees. And I think it would be good if companies would also invest in having an up-to-date stack. And then they can hopefully attract more employees. So I think it's important for various reasons. If we look at performance, so I saw some numbers coming across on the internet. This is for garbage collection for various versions of Java. So the one at the top is Java 16, then the pink one is Java 17, and the yellow one is Java 18, and this is about garbage collects. And yeah, you see that it's actually improving. It's not simply that I say that performance improved, but it's actually improving without you having to do any code changes, basically. I mean, you simply upgrade to the latest version and you get performance improvements for free. There are also some reasons why maybe you don't want to upgrade, because it's quite a bit of work. You have to upgrade not only your local machine, but also build environments, deploy environments, your frameworks and stuff like that. It can be quite a bit of work. I've also heard that some people are scared to upgrade because of the Java 9 modules, or Jigsaw as it is called, because many people thought that when they upgraded to Java 9 or later, they had to use the new module system, and that's actually not true. The JDK itself uses the module system, but you as an application, you can choose whether or not you want to use that. And I think like maybe 95 or maybe even 99% of the applications don't use the module system themselves. So it's not something that you have to do. It's an optional feature, like, yeah, using certain methods in the JDK or whatever. You're free to use them, but it's not mandatory. One interesting feature, I think, is if you create an application that's being run at your customer site or in some clouds of your customers, and those machines maybe still run on older versions of Java and you're not able to upgrade them yourselves. There is a quite nice feature already around for a while, but a lot of people are unaware of it, and it's called multi-release jar files. With multi-release jar files, we can actually use various Java versions within one jar file. So I created an example. I will show it in IntelliJ in a second as well. So we have the normal Java COM package structure with the application and the student, but we also have a student in a Java 17 package, which looks a little bit different, as I will show you. So we have the multi-release jar file package. So here we have like the classic student. It's a class which is probably familiar to all of you. I have created an isBlankName method, which basically checks if there are any blanks in the name that I supplied. And I have the same student, but this time it's a record, and it uses the new isBlank method, which is available on a string nowadays. I supply some extra information as well. Then I have an application class, which basically prints some information like the version of Java I'm currently using, and it calls the various methods that I created. To use this, you need to have a little bit of configuration. So I configured it with the Maven compiler plugin. So I say that the normal stuff in the Java package should be compiled with Java 8. And I also want to compile some items on Java 17. And that's the stuff that's in the source main Java 17 directory. So with this, I can compile multiple versions of Java. I have some Maven jar configuration, but that's mainly to specify the main class. And then I created a Docker file, basically to show you how this example runs on Java 17, then on Java 8, and then on Java 11. So I will build the application on Java 17. I create a jar file out of it. Because Java 17 is the newest version of the code that I use. So I need to compile it and build it on Java 17. And then I will use the exact same jar file. I'm copying it from the previous step on Java 8 and then on Java 11. So let's see what happens when we do that. So let's see where it starts. So we see here Java 17. I see I still have the early access instead of the general available one installed. So that's something I need to fix. But you can see that it's using the record implementation. And then when we go a bit further, we see on Java 8, it's using the Java class implementation. And on Java 11, it's also using the Java class implementation. So for all Java versions older than 17, the regular code is being used. For everything on 17 or newer, the Java 17 code is being executed. So that might help you to use like new methods or new features in the JDK and run that on the new versions of Java while still being compatible for old versions of Java. And those customers, they might have slower performance because you cannot use all the new stuff in the JDK that's available. But at least the application still runs for them. And it's, I think, a good incentive for them then to upgrade their application. One thing to keep in mind, in my case, the student example, it should have the same public API, so the same methods and things like that on each version of Java, because else you will get runtime issues. Build tools don't give an error on that. However, your IDE, in my case, IntelliJ, warns you if the API is different. And nowadays, you can also validate it with the jar command that's displayed here. Then I think in the past, when I did Java upgrades, it was a bit more cumbersome because build servers and production environments and test environments, they all ran on an old version of Java and were mostly maintained by other departments. So other departments first needed to make sure that either 2 versions of Java were installed, or we somehow had to make sure that one was installed and we would migrate at the same time as they would update their Java version and stuff like that. Nowadays, within our company, we use Docker in both the build environment and the test and production environments. And that basically works as an abstraction layer. Every team can decide for themselves when they want to switch to a new version of Java and do it whenever they have time for it. So I think things like Docker or other abstraction layers, they help a lot in making it easier to upgrade to the latest version of Java. So yeah, why do I do this session? Basically, because I saw that there are a lot of cool sessions about new features in Java, but I also noticed that a lot of people are still on old versions of Java. So I'm wondering, let me know in the chat, which version of Java are you running on in production at this point in time? Another reason was that I often see that it's difficult to estimate, and it won't get easier after this session because I still have troubles estimating. But I think there is a difference between estimating is difficult and simply calling really huge numbers, which is something I often see. I had projects that estimated the migration from 8 to 11 as being weeks to months of work, while I actually migrated that application in a couple of days. That was partly due to my experience, but also due to the fact that you simply need to get started and figure out how it's going. So it can be a bit of a challenge, but I think with this session, we might make it a bit easier, basically by focusing on issues that I saw that were recurring across multiple projects, as I'm upgrading multiple projects now as well to Java 17, to provide guidance on those recurring issues so that you can focus on the stuff that's specific for your application. I use Maven as an example, but of course, Gradle works as well. So for Java in the past, it was relatively easy. There was a big release every 3 or 4 years called the long-term support or LTS release. Then they switched to releases every 6 months, and every 3 years it would be an LTS release. Recently, it was announced that we will get LTS releases every 2 years, so that's a bit different again. Those versions in between, like version 12 until 16, those are perfectly usable on production environments. It's not like a beta release or something like that. You can easily use them. It's no issue at all. I think the main thing you need to be careful about is that in general, most vendors only offer minor upgrades for non-LTS versions until the next version comes out. So Java 12 got like 6 months of minor updates, and after that, there were no more minor updates from most vendors, except for Azul, I believe. They offer longer support. So that's a bit of a challenge. You need to make sure that you can regularly upgrade if you want to stay on the latest version of Java, because else you cannot even do minor upgrades with the latest security fixes and things like that. So that was, for us, the biggest reason to stay on LTS versions for now, because we think it will be a challenge to update every 6 months. And that's also what I see and what I hear when I give this session before, that most people stick to the LTS releases, maybe until like Java 18 or some of those versions releases some really cool features. Then, of course, it's a decision that needs re-evaluation. So which one to pick? For us, it was the LTS version, but it might differ in the future as well. I think LTS makes it just a little bit easier to keep up to date with the latest minor versions. Then a bit on what do we need to actually upgrade. If we look at an application in general, you have some application code and you have some dependencies, unless you're really adventurous and build the entire application yourself and don't use any dependencies. And then we have Java or the Jdk or the JRE, whatever you're running on, and something is removed there. So then either your application code or your dependencies might break because they use something that's actually being removed. And as they sometimes say, a lazy developer is a good developer. It sometimes pays off to be lazy. If you wait until your dependencies resolve the issues with the latest version of Java, you can simply upgrade to the latest version of the dependency and you're good to go again. And when we talk about stuff that's being deleted from the JDK, often it's not being deleted at once. The JDK often starts with deprecating features and then later removing them. So if you look, for instance, at JuxB, it took a couple of iterations before it was actually removed. Before that, you got already deprecated messages. So if you keep up to date with the latest version of Java, make sure you fix all the deprecated issues. Then by the time it's being actually removed, you shouldn't have any work at all. And what can be removed? That can be actually anything. We will see some examples later, but it can be anything. I listed a few things here, so anything can be removed. If you want to see more in depth on what's being added or removed, there are several websites that help you with it, such as the Java Almanac. Let's show that simply in a browser. So this is the Java Almanac, which shows every method that's being added and every on low level what's being added, removed, or deprecated. Probably not a good idea to try and remember all these things, but it can be helpful if you upgrade from one version to the other and you get things like method not found exceptions, then you can check whether it's actually removed or what happened to the method. The same information is also available on the Fujay website with a bit of a different look and feel, so that can be helpful as well, depending on which look and feel you prefer. There is some other information available as well on the OpenJDK website. All the Java enhancement proposals, or JEPs, are mentioned. Those are the higher level features. You won't see the methods that are being removed here, but more like bigger features that are being added or removed. There are the Oracle release notes. Lots of information present here, including things that are being removed. And Oracle also nowadays has an Oracle JDK migration guide with a lot of information and the changes that happened within each version. If you want to see this information, you can also have a look at the GitHub repository I created. So a lot of the links are available in here as well, and I will add the links that I haven't put in here yet later as well. I think most of them are present. So this shows what's being changed in a version of Java and what errors you get when you upgrade to a new version of Java and how to resolve those errors. So this might be helpful for you to upgrade your application. So we've looked at these as well. Then there are different ways to basically make sure you run multiple versions of the JDK, because if you upgrade to a new version of Java, you might still want to run the old version of Java so that you can still do bug fixes on your application and things like that. So there are different ways to do that. I listed a few here. I use Docker for some of the examples because I simply like to use Docker, and it's make sure that you don't have any operating system or local configuration issues. I for once had a project that I upgraded, and I got really strange errors, and I couldn't figure out why it went wrong with the new version of Java. And then I ran it in a Docker image, and I figured out it wasn't even a new version of Java issue, but it was simply an issue that the code didn't run on Windows. And as soon as I ran it in a Linux Docker image, everything was perfect. So Docker is sometimes helpful, but the feedback loop is a bit longer because you need to build the Docker image and then run it. So when you're actually doing the migration or the upgrade to Java 17, it's probably more helpful to make sure you have a JDK installed on your machine and use your IDE to upgrade things and get continuous feedback. However, if you want to try some things in Docker, I think Docker is fairly popular now, but if you haven't used it, it's not really a problem. It's fairly simple. So if you install Docker, then you create a so-called Docker file. You specify what base image you want to use. I want to use a base of Maven with the latest Java 17. I add my project, and then I basically run Maven. So this is the specification. If I want to execute these steps, I can simply say docker build -t. I give it a name, in this case Java upgrade, and then I specify the dot. The dot is not the end of the line. The dot is specifying the context that needs to be built, and in this case it's the current directory. So don't forget the dot. It's a common mistake that's being made when you start with Docker. And that way you can easily run your examples. Then if you roll out a new environment in general, you start with your local machine, then the build environment, and then the deploy environments. And then it can be a bit of a needle in a haystack if you upgrade from 8 to 17 at once. You don't know what version caused the issues. So it might be helpful to upgrade to a lower version and do it step by step, for instance, from 8 to 11 and then from 11 to 17. Both is possible, but if you get weird errors and you cannot really Google for them, might be helpful to do those shorter steps. So for the ingredients, make sure you upgrade everything. Also your plugins, compilers, and things like that. For Maven, it's nowadays configured like this. Make sure that everything is running on Java 17 and not running on some other version installed on your machine. Upgrade your dependencies. That's like 99% of all the work of upgrading to the new version of Java. If your dependencies are up to date, upgrading Java is often a breeze. often works at once, actually. And make sure that you also check for new artifact or group names. Sometimes dependencies get a new name because they are forked. And for instance, Java EE is nowadays called Jakarta, so there are some new versions. So there are some tools available to make sure that you upgrade to the latest version. You can use these versions plugins to see what the latest versions are that are available, but there are also plugins available that automatically upgrade all your code or dependencies to the latest version, such as tools like Renovate, which creates pull requests for you. If you, however, have a new package name, those tools in general cannot, they will simply pick the latest version, but the latest version is an old version because there is a fork of it. In that case, you can use the old group IDs alerter plugin, which will notify you if you have issues like this. So there are various plugins to make sure your dependencies are up to date. And I cannot emphasize it enough. Make sure they are up to date. It's not only good for your application because you have a lot of benefits by it, but it's especially helpful if you upgrade Java, then it will be really easy. Upgrading, please try to do it step by step. Start by compiling, then running tests, or maybe first compiling tests and package the application and test the running application. It helps a lot to do it step by step. Then you can say, this runs, this doesn't run yet. Instead of saying, I think I'm 80% done, I still need to do 20%, because everyone knows those 20% is like at least double the amount of time of the 80% you have done before. So I think this helps better to do it step by step. And then you end up with a really nice pizza. So now it's time to look at what's being removed from the various versions of Java. In Java 11, JavaFX was removed, more or less to create a nice front end for your application. You can nowadays use either separate builds, but the interesting fact is it's removed from the Java specification, but there are still vendors who offer builds of the JDK that still include OpenJFX and some other things that are not in the specification. For instance, the Liberica full JDK or the OJDK build, they offer builds that still include OpenJFX, so you could use those as well. Or you could use the Maven dependency. Another interesting thing is the fact that the JDK fonts have been removed. In the past, there were a few fonts present in the JDK. So tools like Apache Poi, which works with Word and Excel documents, could use those fonts basically when it operated. Nowadays, they are removed from the JDK. And then basically the JDK will look for the fonts on your operating system. However, if you have a really small operating system, it doesn't have any fonts either, like for instance, Alpine Docker images. So then you will get an error, weird font errors, and that basically means you need to install some fonts on your operating system to resolve the issue. Java Mission Control has been removed. If you don't know it, Java Mission Control is a really helpful tool to monitor and profile your application. I can really recommend looking into it. It's separate builds by various vendors again, so it's still easy to use. The one with the biggest impact is probably the removal of the Java EE and Corbin modules. I hope not Corbin. I hope you're not using that anymore. But Java EE, things like JuxB, they have been used in a lot of applications and are still being used. To resolve that issue, basically you need to add dependencies. And you can either add the old JavaX dependencies who are no longer maintained, or you can add the new Jakarta dependencies. In case you add the new Jakarta dependencies, you of course also need to change all of your imports. So it might be also an idea to first use the old dependencies to make sure you're running on Java 17, and then as a next step, upgrade everything to Jakarta and change all your imports. I've heard of some projects that took those steps. That's also perfectly fine. You can see on the left the old modules, and on the right you can basically see the replacement artifact IDs from the Jakarta project. For JuxB and JuxWS, you need two dependencies, one for the API and one for the implementation. For Glassfish, provides a Corbin replacement because there is no official replacement. Java 15 removed the Nashorn JavaScript engine. I always thought it wasn't used that much in projects, but I actually encountered it in one of my projects that I upgraded to Java 17. I got Nashorn errors, and I could simply add the dependency, and I was still good to go. One of the things we're seeing in the latest versions of Java is the encapsulation of the Jdk internals. So the Jdk methods that are basically not meant to be for us normal developers, but more for developers of the JDK itself. In the past, they couldn't hide away those internals. Later, when Java 9 came, they could, of course, use the module system to shield those internals away. But there was already some older internal logic present, and they decided not to shield that away because it would break a lot of applications. So instead, they left that part open. But in Java 16 and later, well, in Java 17, as we will see, they tried to shield that away more and more and making it more and more difficult to use it. Solution, again, like for most problems when upgrading Java, is make sure you upgrade your dependencies. So I built one of our projects on Java 16, got issues because Lombok uses those internal Java elements. But within like 2 weeks of the release of Java 16, Lombok released a new version, which actually fixed those issues. So I could simply upgrade Lombok and I was good to go again. There is also a workaround. You can specify compiler arguments. This example uses Maven for it. And basically here we say that all the modules that are basically closed by the JDK, we want to open them again. Of course, that feels a bit dirty. It says if someone puts a lock on the door and you remove the lock from the door. It should be really only used as a workaround if you cannot do otherwise. Normally, if you upgrade your dependencies, and sometimes you have some code you wrote yourself which uses these internals, then rewrite that code. And in general, I have to say I only encountered once in one of our projects that we used internal Java code in our code itself. And that was in a unit test, and I could easily rewrite it. So I didn't need to use these dirty tricks basically to keep on running. So I don't advise this, but yeah, it's an option. The other option in Java 17, instead of specifying all the modules that need to be opened, we can also launch Java with the -- illegal access modifier. And then basically we can have access to everything again. Which again, I think is quite a bad idea. Try to really fix it. There are new higher level APIs available, so make use of them and upgrade your dependencies. So this is an example of an error you can get when you use an older version of a dependency, which uses those internals. So this says basically that the compiler module does not export the processing to the unnamed module because I don't use modules in my application. So errors like this indicate that you're using internals. For Java 17, the applet API has been deprecated for removal. AOT and JIT compiler has been removed. If you want to do things with that, you can have a look at the Gradle VM project, which does a lot more with that. Again, we see that there is a JAP 403 in this case, strongly encapsulate JDK internals, which again makes it more difficult to access those internals. And the security manager is deprecated for removal. So strongly encapsulate JDK internals, what does it mean compared to Java 16? It means that you can no longer use the -- illegal access command to start up Java. It won't work anymore. So again, the solution is make sure you upgrade your dependencies for your own code, rewrite it using the newer JDK APIs. Unfortunately, you still have the last resort workaround, which was also available in Java 16, and that's using the -- add opens. You can use that, for instance, for your unit tests like this with Surefire. Again, I really don't recommend it. Make sure that you fix these issues because maybe in the next version of Java, they will put a lock on it completely without any workarounds, and then you have to fix it anyhow. And when we look at the Java 17, I tried a lot with early access versions of Java with different projects, and I noticed not everything worked out of the box. For instance, if we have an enum with a field test, which then contains a method, if I would mock it with Mockito, I would get an error like this. However, it's fixed in the newest version of Mockito. I simply filed an issue and they fixed it in a matter of days, basically. So again, if you upgrade your dependencies, then probably a lot of the issues that you see are already resolved. For the Kotlin Maven plugin, I tried to run that on Java 17 as a JVM target, but I got a really clear exception, unknown target version 17, so it wasn't supported yet. I checked quite recently, and I think the latest version still doesn't support it. Probably sometime in the future they will support it. For now, you can simply use Java 16 to run on Java 17 as well. So that's the workaround for now. For Gradle, it's actually interesting. I never really paid attention to that before migrating to Java 17, but Gradle is more tightly coupled to the Java version than Maven. So Maven supported early access versions of Java 17 already from the beginning. However, Gradle had some issues with that. So I think the version of Gradle which supports Java 17 still has to be released. There are some ways to get it up and running, but it's a bit more hassle than with Maven. So if you want to stay on like the latest version of Java and want to try out early access releases, then Gradle probably isn't the best build tool for that. But in the end, if you wait, it will work as well. We see that unsupported class file major version 61 in various areas. I've seen it with Jacoco as well. So it's an interesting error. And at first I didn't know what it was, but of course, I mean, Google is your best friend and you see it everywhere in Maven plugins. What does it mean? Basically, class file major version 61 depicts the class file version that's being used for Java 17. So class file major version 60 is used for Java 16. What does that mean again? It means that you're using some stuff that doesn't work on Java 17 in this case. So I've seen that with mocking frameworks and test tools which used some of the internals of Java. They weren't compatible with Java 17. So again, I could upgrade those dependencies and then automatically this error disappears. And then we're there. So if you want to look at some of the examples on things that broke or that I fixed, you can look at the GitHub repository. You can also run them with Docker and you can see what fails or throw in your own example code where you're curious if it will work on some version of Java or the other. And then you can use all those cool features finally, like records, like pattern matching, all those cool and hip things. Finally, you're there after all the hard work. But I think the amount of hard work, you should give it a good thought. So I think in general, upgrading from one major version from one LTS version of Java to the other LTS version of Java, in general, it's a couple days of work. I think most of the time I spent like 2 or 3 days, and it's mainly working or waiting for builds to finish actually. If you make sure your dependencies are up to date, I think you can even do it in a matter of hours. So it's actually, it's not the challenge of upgrading Java. The challenge is often in upgrading the dependencies. To give an example, for some of the projects, I needed to upgrade to the newest version of Mockito. And some of the code that we had was still on a really old version of Mockito. And a lot of stuff from Mockito had been removed or changed in between those versions. So I had to rewrite quite a bit of the code there. So the work was in things like that, upgrading dependencies and then making sure our code was compatible with the dependency. Then upgrading to the latest version of Java often worked as a breeze. Like I mentioned, I had one unit test that I needed to rewrite, but for the rest, I didn't need to change a lot. I think only some configuration in POM files and things like that. So I would say upgrading a matter of days. 8 to 11 might be a bit longer than 11 to 17 because there you need to make sure that you have the Jakarta or the other JuxB and other Java EE modules imported as dependencies. The others from 11 to 17, actually, I saw that it was relatively easy once all the dependencies were up to date. Try to do it incremental, like I said, do it step by step. So you can tell others and also yourself of the progress, and that also is motivating, because I think a lot of times, myself, I complain about business and management not giving us time to upgrade to the latest version of Java. But I think we should consider that we're all responsible for it. And I think we as developers maybe have the most benefit actually from upgrading, because we can then use all those cool new features. So what I often did was simply on a Friday afternoon when my hours were nearly finished, I made sure that I upgraded parts of it, and then later I could continue. And could say like, oh, it's probably like 1 or 2 more days of work. And then that convinced the management like, oh, it's 1 or 2 days, that's doable, instead of saying like, I don't know it, or yeah, worst case, it's like 2 months of work. I mean, you probably won't get the time for it. So make sure that you are actively working to get your Java version to the latest version. And it's really a matter of simply get started. So that's my biggest tip. Make sure that you get started, and don't make it too big. And that's basically it. If you have any questions, you can still quickly ask them. We have a couple of minutes left, I see. Or else contact me later through one of these ways. And please, yeah, also rate the talk and let me know if you have any improvements, things I forgot, or other feedback, so I can continuously improve this talk for others. And hopefully together we can make sure we get to the latest version of Java in an easy way.